Section 6.1, Fundamental Trig Identities. All right, there's a bunch of identities. I'm not going to list them all on this board. Just look at the notes that we have posted on Moodle, and you'll see the identities. Most of them you probably already know. All of them you have actually already seen in this class. But let's take a look at these particular Pythagorean identities here. We need to memorize these identities. Now, if we don't have them memorized already, we need to memorize those. We need to memorize all the ones for the notes and so forth. Well, a lot of people don't have trouble at all memorizing the sine of x squared plus cosine x squared is equal to 1. But a lot of people have trouble with these two. So let's try to simplify this. Instead of not simplifying a math sense, but simplify the memorization of this. All right, let's see. Since most people don't have trouble memorizing this one, you already have that in your memory bank. All right, so think about it this way. If you have trouble with these two, think about what if we divide both sides of this equation by the sine of x squared? Or take each term, divide by the sine of x squared. What do you get? You get 1 here is equal to, equal, plus. I could write this as the cosine of x over the sine of x, quantity squared. It's the same thing as that. It's equal to, I could write this as 1 over the sine of x, quantity squared like that. If I square that out, that would give me the same thing. All right, so I have 1 plus, what's cosine over sine? That's cotangent, right? So I have cotangent of x, what? Squared is equal to, what's 1 over sine? Cosecant of x squared, right? Or I could do a rewrite and say that's 1 plus cotangent of x squared, but put the square there, is equal to the cosecant of x squared, but put the square there. What does that look like? It looks like this identity right here, right? All right, how about the other one? Well, let's start out with sine squared plus cosine squared is equal to 1. And this time, let's divide both sides or each term by the cosine of x squared. So if I divide by the cosine of x squared, I can rewrite this as the sine of x over cosine of x squared plus, well, that just gives me 1, right? It's equal to 1 over cosine of x squared like that. Now, what's another identity or what's another name for sine over cosine? Need a tangent, right? I need it squared. Plus 1 is equal to, what's another name for 1 over cosine? Secant of x, but I need it squared. What does that look like? That looks like the second one, right? So if you're having trouble, struggling on a test or whatever, can't remember, just divide by sine and just divide by cosine. You got the other two. All right, so now we're going to get into section 6.1. All right, this now, be patient, is a harder section usually for students. All right, we're about to see why. Well, this first example is not too bad. It's whenever we get to verify. But let's look at this first example. It says, simplify each expression, write the final form with no fractions. All right, then we have cosine of x times tangent of x times cosecant of x. All right, so what does it tell me to do? Simplify. All right, let's write this in a simpler form. So I'm going to have cosine of x right here. Now tangent, let me go ahead and convert that to sine of x over cosine of x. And cosecant, let me go ahead and rewrite that as the reciprocal, 1 over what? Sine of x. Now the reason why I did all that is because I looked ahead. I said, what if I were to make this sine over cosine? That would make the cosines divide out here. Then if I had sine over cosine, it would make the sines divide out there. So let's put the cosine over 1. These cosines divide out. You left at 1s. These sines divide out. You left at 1s. So what do you have in the numerator? 1 times 1 times 1, which gives you 1. How about your denominator? 1 times 1 times 1, which is 1, which just gives me 1 as my simplified form. Part B. How about for part B, we have sine of x squared plus 1 over cosine of x squared. And then over here, we have plus 1 outside of the fraction, okay? Let's try to simplify this. Well, here, I could write each form, or each part of my numerator over my denominator. In other words, I could write sine of x squared over cosine of x squared plus 1 over cosine of x squared. So let's do that. Let's say this is a sine of x squared over cosine of x squared plus this 1 over the cosine of x squared, and then plus this 1 on the outside. Well, I could do a rewrite here. I could say, all right, this part right here is really the sine of x over cosine of x quantity squared. I guess I could do the same here, right? I can write that as 1 over cosine of x quantity squared plus 1. Always double check yourself. Say, what happens if I square this right here? I'll get numerator squared over denominator squared, which is what I have. What happens if I square each one of these, numerator, denominator? I will get that. All right, which identity can I use here for sine over cosine? Yeah, you guessed it, tangent, right? So that's tangent of x squared plus, what's 1 over cosine though? Isn't it the secant? So that's the secant of x squared, and then plus 1. What did we have on the board earlier? What's the very first thing we did? We verified some identities, right? And didn't we have an identity that had the tangent squared in it? So we had an identity, a Pythagorean identity, that looked like the tangent of x squared plus 1 is equal to the secant of x squared, right? Well, there are a couple of different things I could do here. Here's one thing I'm going to do. I'm going to say, what if I get this tangent of x squared next to this 1, or if I get the 1 and place it over here? That'll be the tangent of x squared plus 1 plus the secant of x squared, right? Now, what's the tangent of x squared plus 1 equal to? Secant squared, right? So I can replace this part with the secant of x squared. Then let's bring down the secant of x squared there. What's the secant of x squared plus the secant of x squared? 2 secants of x squared, right? There we go. There's a simplified form. They wanted no fractions, so I'm not going to turn that back into 1 over cosine squared or anything. All right. Let's see. We looked at some identities and we simplified some stuff using some identities. Let's look at the sine of x squared plus cosine of x squared is equal to 1, okay? We call this an identity because it's true for any value I plug in of x here that'll make this equation, or that'll make each one of these sides of my equation defined, okay? So any number that I plug in where this thing's defined, it'll make a true statement. So this is an identity. Now, let's compare that to something that's not an identity. See what the difference is. All right, let's suppose somebody had this. Sine of x plus cosine of x, and they said, hey, this is an identity. I would say, no, it's not. But then they would try to convince me. They would say, what if x is equal to 0 here? Then they would say, all right, sine of 0 plus cosine of 0. That's going to equal to 1, isn't it? What's the sine of 0? Well, that's 0, right? What's the cosine of 0? Think about your unit circle. That's 1, right? What's 0 plus 1? 1. That is indeed equal to 1, right? Therefore, I've proved that this is an identity, somebody might say. But you say, oh, no, absolutely not. Because why? Well, you might say, your argument might be, well, what if x is equal to pi over 6, you might say. Then you might say, okay, if I have the sine of pi over 6 plus the cosine of pi over 6. Let's see what that calculates to. Unit circle time. What's the sine of pi over 6? A half. What's the cosine of pi over 6? Square root of 3 over 2? If you add these up, you get 1 plus square root of 3 over 2, right? Well, this definitely is not equal to 1, right? That definitely is not equal to 1, is it? So you would say, no, it's not an identity here, because why? I could find a value of x I sub in here that makes it not a true statement. All right, so the whole point of all this mess was here to show you that what an identity is a statement that's true for any value that I input into it that makes it defined, okay? Whereas the top one was an identity, the bottom one is not. And you can think of this like a liar, this statement right here. How many lies do you have to catch somebody in to be able to call them a liar? One, right? Didn't I just catch this thing in a lie right here? I said, no, it's not equal to 1. That's a lie. So therefore, this one's not an identity. All right. Now, here's where the more difficult part comes in. Verifying identities. Verifying identities. So we want to show like these identities are true for every single x we can think of that makes it defined. All right, so if you look at your notes, you have guidelines for verifying identities. That's going to make a very boring video if I sit here and write those all up and read them off to y'all. So you can pause the video now, look at your notes, look at the book or whatever, and look at those general guidelines, okay? Now keep in mind, those are guidelines. That doesn't work. They say like, try this, try that. There's no nice formula that works every single time if you try it. All right, what if we're told to verify the identities? Well, 1 over secant of x minus 1 minus 1 over secant of x plus 1 is equal to 2 times the cotangent of x squared. So I want to show that this is true. I want to show that one side is equal to the other side, okay? Now, when I'm verifying that these are identities, what I do is I work with one side and one side only, make it look like the other side, okay? Usually what you do is you start out with your more complicated side. Well, obviously the left side is more complicated. So I'm going to start out with the left-hand side. I'm going to say 1 over secant of x minus 1 minus 1 over secant of x plus 1. Erase this. It just looks like a double fraction or something. All right, so I start out with the left side. And let me manipulate the left side to make it look like the right side. Now, keep in mind, where are you headed here? You're headed to this part right here, trying to get your endpoint here. Notice what you have. Two fractions, right? You have two expressions here, basically. You're trying to make them into what? 1. So the first thing that comes to my mind is, let me subtract these two. Well, to subtract them, I need a common denominator, right? So I'm going to multiply the top and the bottom of this one by this one's denominator. In the second fraction, I'm going to take the top and the bottom and multiply by the other one's denominator. So I'm going to write this down, 1 over secant of x minus 1. And I'm going to multiply the numerator and denominator by the denominator of the other one. I'm just trying to come up with a common denominator. Minus, now bring this portion down, 1 over secant of x plus 1, and I'm going to multiply by the other one's denominator, top and bottom. Secant of x minus 1 over secant of x minus 1. Well, 1 times this expression secant of x plus 1 is secant of x plus 1. Now at the bottom, what happens if I multiply these out, or if I try to use FOIL or distribute or whatever? I'm going to end up getting secant squared minus 1. Over here, I'm at my minus side. 1 times secant of x minus 1 is secant of x minus 1 over this denominator. If I multiply it out, I will get secant of x squared minus 1. Okay. Notice we have the same denominator here and here. Got to come up here because I'm out of room. We have the secant of x squared minus 1. I just write that one denominator down. And then the numerator is going to be secant of x plus 1 minus this stuff over here. Secant of x plus 1 minus this numerator, secant of x minus 1. Hold on, let me check the camera again, make sure I'm still in view. Yeah. All right, so this is the secant of x plus 1. Now distribute your negative through here, and you get minus secant of x plus 1 over secant of x squared minus 1. Now up top, bam, bam. And what is 1 plus 1? 2 over secant of x squared minus 1. Now, what am I shooting for? Don't forget what I'm shooting for. I'm shooting to make this part still look like that, right? So let me see how I can make that part look like that. Now, I got to erase some stuff here, okay? I'm out of room. Well, think about your Pythagorean identities, okay? Think about the one that you had with what secant squared in it. Now, why am I thinking of the one with secant squared? Because I have secant squared right here, and I have a 1 right there, okay? So that tips me off the Pythagorean identity. What was that Pythagorean identity? Tangent squared plus 1 is equal to secant squared, right? Didn't we have that? Well, sometimes you have to play around with these identities. This is just scratch work what I'm doing now, okay? To make this part look something like that, what I'm going to do is move this 1 over to the other side and write this as tangent of x squared is equal to secant of x squared minus 1. Now I have secant of x squared minus 1, secant of x squared minus 1. So what could I put in the place of this one right here? I could put in tangent of x squared. Well, I'm still shooting for this, right? So let me rewrite this as 2 times 1 over tangent of x squared like that. That's 2 times, what's 1 over tangent? 1 over tangent's what? Cotangent. So that's cotangent of x, but we need it squared, right? All right, wait a minute. Is that where I was headed? Sure is. I'm done with this problem. Now, I do not box this in because my answer is really all that work that I did leading up to it, okay? That's the important part, all the work that led up to that. All right, as you can see, these are generally harder than regular old math problems. But it's some really good stuff if you're going on to take more math classes. You're going to need to know this stuff for sure. Let's look at part B. Part B is in boy. Part B is in boy. Part B, we're going to have 1 over sine of x minus sine of x squared is equal to 1 over I'm sorry, 1 plus sine of x over sine of x times the cosine of x squared like that. Erase all this stuff. Still trying to verify the identity. Still trying to verify the identity here. Now remember, what I'm going to do is I'm going to start with one side and I'm going to attempt to make it look like the other side here, okay? Remember, you do not want to start messing around with both sides here. Just one side. One side, I guess, doesn't really look too much more complicated than the other. So I'm going to start with the left. Now, I'm starting with the left here. You and your buddy might work on these problems together. They might start on the left-hand side. You might start on the right-hand side, but you'll both verify. And that's fine. You know, some of these problems, there's more than one way to verify. In fact, most of them, there's more than one way to verify them, as long as you're showing all your work step by step and using appropriate algebraic techniques and appropriate identities too. All right, so let me start out with this side, make it look like that side, okay? Let me see. Maybe what I'll try to do is factor a sine of x at the bottom. 1 over sine of x times, let me write this a little better for you. All right, let me write this as 1 over, what if I take a sine of x out of each one of these? What am I left with here? A 1 minus, what am I left with here? Sine of x like that, okay? All right, now, what am I shooting for? I'm shooting for 1 plus sine of x over sine of x times cosine squared, right? Now notice I have that sine of x right here. But what do I want next right here? I want cosine squared. So I'm going to think of an identity. Sine squared of x plus cosine squared of x is equal to 1. And on this identity, if I end up, say, let me see how I can explain this. If I end up subtracting the sine squared from both sides, then I will get cosine squared, right, on this identity. I'm just playing around with this stuff, just doing scratch work over here, okay? So if I can get 1 minus sine squared, that's my cosine squared, right? I have 1 minus sine. If I can make it 1 minus sine squared, I can replace it with cosine squared, which is what I want. Well, I could do that if I multiply by its reciprocal, by its conjugate. I'm sorry, by its conjugate here. So I'm going to take 1 over sine of x here times 1 minus sine of x, and I'm going to multiply the bottom of it by the conjugate of this part, 1 plus sine of x. 1 plus sine of x. Well, what I do to the bottom, I got to do to the top here, right? Hold on. Make sure I'm not off the screen. I don't think I can go one more step down. Maybe. All right, let's see. So 1 times this part is this part. 1 plus sine of x, right? How about the bottom? I have sine of x times, what happens if I multiply this part and this part? If I use FOIL, if I use distributive property or whatever, I'm going to get 1 minus sine of x squared like that. Am I still on the screen? Yeah, sure am. All right. So I have 1 plus the sine of x. I'm just going to recopy it here, okay? Over sine of x times 1 minus sine of x squared. But what did we say a little while ago over here? We said cosine squared of x is equal to 1 minus sine squared of x, right? Well, what's 1 minus sine squared of x? What can I replace that with? cosine squared. So we have 1 plus sine of x over this sine of x comes down, but 1 minus sine of x we're going to call cosine of x squared. Does that look like where I was trying to get? Sure does. All right, let's see. A lot of people are so tempted to work with both sides, start multiplying both sides. No. Why not? Why do you not do that? Well, one reason, because mathematically it's not right. But let me give you an analogy, okay? Let's say that you have one person, okay? And this person maybe looks like this. Yes, I was an artist one time. Hopefully you don't believe that. All right, let's say these two people, you say that these two people look alike, okay? I don't know, call them something. I don't know, Angie and I don't know, what's another common name for a lady? Mary. Maybe I'm showing my age there. All right, let's see. What if you say Angie looks like Mary? Somebody might say, no, they don't. Well, what if you take Angie and you give her different shape eyes like Mary? Okay, so you start out by giving her different shape eyes, okay? Then you say, okay, well, let me alter her look a little more, okay? Let me take Angie and give her short hair like Mary, okay? Then you might say, okay, well, let me take Angie with the short hair, with the eyes like Mary, the smaller eyes like Mary, and make her mouth shape the same, okay? Guess what? She's starting to look like Mary, right? Only because we altered this. But what if we said, instead of doing that, we said, I think Angie looks like Mary. Because if you take Angie and you alter maybe her eyes, make her eyes a little smaller, then you take Mary and you say, okay, well, let me make her hair longer. And then let me take Angie maybe and then make her smile different. Let me take Mary maybe, make her smile a little different. And therefore Angie looks like Mary. No, they both look like somebody else, right? We altered both of them to make them look alike. To say that Angie looks like Mary, you can only alter one of them, Angie, to make her look like Mary. Or you could go the other way, take Mary, alter her to look like Angie, then Mary looks like Angie, right? But you don't work with both of them at the same time. All right, let's get back to verifying identities. I think we did B. Let's look at C. C is in cat. 2 times the tangent of x to the 4th plus 7 times the tangent of x squared plus 5 over secant of x squared is equal to 2 tangent of x squared plus 5. Oh, this one's messed up, Mr. Font. No. Yeah, well, sometimes in life we got to deal with messed up stuff. All right, let's see how we're going to work with this. Well, definitely which side looks more complicated. Now, okay, keep in mind, these are guidelines. Usually you work with a more complicated side. Not always. Sometimes you work with that and you don't get anywhere, so you do the other one. But let's start out by trying to look at this more complicated side. 2 times the tangent of x to the 4th plus 7 times the tangent of x squared plus 5 over secant of x squared. All right, now, how do I make this look like that? Well, I'm not seeing identities right off the top of my head, okay? Yeah, there is a tangent square, but I'm not seeing like a 1, a plus or minus 1 with it. So I'm not going to use Pythagorean identity there. What I do see, though, is I do see that this looks like a factoring problem. Probably thinking, what? Well, what if we did this? What if I said 2x to the 4th plus 7x squared plus 5? Let's suppose we looked at this. All I did here was I took each tangent and just replaced it by x. Wouldn't you say you could factor this? You can say, okay, this is 2x squared times x squared. This is 5. That's 1. As long as I make them plus and plus, that'll factor, right? Go ahead and check it for yourself. Multiply it back out. That's really similar to what we have here, but instead of x's, we have what? Tangents of x. So in other words, I can factor that top. I can say that this is 2 times the tangent of x squared. I could say that this is tangent of x squared. I could say that this is 5. I could say that's 1, and I can put pluses. Now, what do? We just took the place of each, what, tangent and put it in x part. So that's my numerator over secant of x squared. Where'd that get us? Oh, I'm so glad you asked. Let's see. What was our identity that had the Pythagorean identity had the secant squared in it? Didn't it look something like this? Tangent squared plus 1 is equal to secant squared. So we're saying that what? The secant squared can be replaced with tangent squared plus 1. So I'm going to replace this with tangent squared plus 1. So I have 2 times the tangent of x squared plus 5. I can certainly write better than that. I'm not a 5-year-old. Times the tangent of x squared plus 1 all over, what do we say we're going to replace that with? Tangent of x squared plus 1. All right, so what divides out now? This and this, right? So what are we left with here? We're left with 2 times the tangent of x squared. So we're left with 2 times the tangent of x squared plus 5. Hey, that's where I want it to be, right? I verified that identity. All right, let's move on. And let's actually skip D for now. And let's go to E. We'll go back to D. Okay? Actually, I want to do E next. E, we have cosecant of x times the cosine of x over cosecant of x minus the sine of x is equal to secant of x. So how do we verify an identity? We work with one side, make it look like the other, right? Usually, start with your more complicated side. And the reason you do that is because you have more stuff to work with than here. So left side's my more complicated side.